So now quickly take up the questions. So these are just the problems which will be helpful for you to understanding the pattern of the questions that are going to be asked in your assignment and the paper. So the question says that the catalyst that produces the ultra high molecular weight polyethylene is an R. We have already seen that ultra high molecular weight is only coming when we are having, this can be obtained when we have a sandwich kind of catalyst with an amide substitution. This we have seen in case of there is no sandwich. This is not even a cyclo CP group. Only this one. This is a fully sandwich, and we are talking about the half sandwich actually. So this is basically your half sandwich molecule. This one only will give you the ultra high molecular. Now the next question says that the catalyst, the leucocene catalyst, three catalyst which will catalyze the isotactic polypropylene. We have seen that this system is your C2V. This will not give you, this is your C2, and this is having, that is also having the, this one is CS and this one is your C2V again. So this particular moiety catalyst which is having a C2 symmetry, that would give you an IPP. This we have already seen. Because of this K1 and K2, this gives you symbiotic polypropylene. Okay, sorry. So this actually gives you a symbiotic polypropylene. This one, because of this K1, K2, it forms a stereo block, which we have just, and this will, C2 will give you a atactic polypropylene. So this has already been covered with all the four examples. So the right option is your B. The catalyst X in the given reaction is. So we have these reactions. So here if you see, it's an alpha olefin with a functional group. This is your functional group because it's having a nitrogen, and we know what kind of isotactic polypropylene we have found over here. Only this is possible when we are having this kind of system, which will give you a, this is the catalyst which will give you the isotactic one. Now, ter polymer, ter means three, so it comprises of how many monomers? So it is actually a three types of monomers, so it's very straightforward. Then it says the correct statements about the stereo block polypropylene. We have already seen that what is stereo block polypropylene. So it would be having C4 to C100 chain as a one form isotactic, and the other one would be your atactic. So all the carbon chains of same chirality, it is not alternate chirality, it is actually isotactic, it is symbiotic, and random chirality is atactic. So this is basically your iso with same chirality. It is your symbiotic, it is your atactic with the random. And when you are having one block of one chirality, another of another one, that is actually your stereo block. So the option D is right. The sixth one is the polymer molecular weight, which does not vary with your percentage conversion. So this is the session that we have taken in the week 9, if you remember. So in case of your step 4, step polymerization, the step polymerization actually is dependent on molecular weight and percentage conversion like this way. In chain polymerization, it is actually independent. So in chain, it is not dependent on this one. And, and in living polymerization, it's a straight. So which does not vary with the which does not vary with the percentage composition, it's your chain polymerization. So the catalyst that is going to give you this kind of transformation. So, so you know that VOCl3, it is used for your poly, uh, that is for your co-polymerization. So it is for your co-polymerization to give you EPDM, that polymer, so on and so forth. This particular moiety, because it is forming isotactic, which is trans isotactic, cis syntactic and trans syntactic. So this particular combination is possible with your A. The following is an example of third polymer. We have already seen that EPDM is nothing but your ethylene. This is high density polyethylene, which is only made up of one monomer. It is ethylene plus this and 1,4 hexadiene. So it's actually made up of 3 units. It is of adipic acid and some amine groups. So it's only 2 units. So only this one, this is a example of a third polymer. The zircosine sulfuric catalyst, which catalyzes the isotactic, that is very straightforward. We have already seen so many times, writing in the repetitive question. So this gives you the isotactic polypropylene. This is having C2V symmetry. It gives you atactic polypropylene. This one basically gives you the syntactic polypropylene. And this, because of the trans and cis configuration, it gives you a stereo block. So this is very important question. B is the right option. And the last question is the tactic speed of the given polymer. Since one is below, one is down. So it's an alternating chirality. And alternating chirality is nothing but your syntactic. So option D is the right one. So with this, we are also done with your assignment problem. So if you still feel any doubt or you have any question, please feel free to ask so that you will be not having any doubts in next or last session. We will wait a few minutes for your questions and then we can end up the session. If there is any question regarding the problems that we have just discussed or the session, please put your question in the chat box. We have introduced almost everything, and next week would be the last session for this particular course, and then you will be having good exams. If there is no question, so I would be meeting you guys in the next live session at 6 to 8 p.m. Please remember the timings of the session because many of you are joining at 7:30. So almost at that particular time, the session is almost about to finish. So it would be better that if you'll join at the right time, I would be able to help you with your queries and all the doubts. Thank you so much.